Hello everyone, my name is China Satterley, and today I'm going to be doing a video on explaining anomaly detection and data mining. So first let's explain what anomaly detection is. Anomaly detection examines specific data points and is used to identify patterns or instances in a dataset that divert from the norm. Anomalies, also known as outliers, are data points that differ from the majority of the data. Detecting them can be valuable in various applications such as fraud detection, network security, fault detection, and quality control, which we'll talk about later on. There are three anomaly detection techniques that I'm going to be discussing in this video: isolation forests, one-class support vector machine, or SVM, and destiny-based spatial clustering of applications with noise, also known as DBSCAN. So first, let's discuss isolation forests. Isolation forests are an embedded-based anomaly detection technique that isolates anomalies by randomly selecting their features and creating isolation trees. Anomalies are identified as instances that require fewer splits to isolate, exploiting the fact that the anomalies are typically rare and stand out in the featured space. So if you think of it as a isolation tree or a tree in general, they'll pick a random point in the data and see if it can split. And if it can split, it's not an anomaly. But if it can't split, it is an anomaly. And it depends on the numbers that it can split. Moving on, we're going to go to one class, SVM. This is a machine learning algorithm that learns to distinguish normal instances from outliers, so our anomalies there. And it contrasts a hyperplane that eclipses the normal data, and instances falling on the other side of the hyperplane are considered anomalies. So you can think of it as a map. We have our map right here. We'll have our normal data points throughout the whole entire center of the map. But once you start getting to those edges and the data points fall off, those are then considered the anomalies. And then last, we have our destiny-based spatial clustering of applications with noise, which is such a mouthful. It is a destiny-based clustering algorithm that can be used for anomaly detection. It identifies clusters in databases on the destiny of data points, considering instances in low density region as a potential anomaly. This technique is effective in handling data with varied densities. This algorithm, if you think of it in a more of a layman term, this algorithm is a friendly neighborhood organizer, sorting folks based on how close they are to each other. If you're hanging out and you're in a very lightly dense population, you'd be considered a potential anomaly. So if we have a cluster of people here, so we have 10 people in my hand, but there's a dude hanging out on my pinky, he would then be considered the anomaly because everyone else is on my palm. The last thing we're going to discuss in this video is anomaly detections, five ways anomaly detection is used in real life scenarios. So first we have fraud detection and financial transactions. This anomaly detection is widely employed in financial systems to identify unusual patterns or outliers in transaction. It helps to detect fraudulent activities such as unauthorized access or unusual spending behaviors. Then we have network intrusion detection and cybersecurity. This anomaly is critical for identifying unusual patterns in network traffic. It enables the detection of potential cyber threats or intrusions by flagging abnormal activity in real time. And third, we have healthcare monitoring of diseases outbreaks. So in this anomaly detection application, it is applied to health data to monitor patterns and identify potential disease outbreaks. Sudden spikes or unusual patterns in a patient's data can signal the emergence of a disease, allowing for early innovation and contaminant measures. And fourth, we have manufacturing quality control. Now, this is normally the one that everyone thinks about in the real life sense when talking about anomalies. It's the manufacturing process when anomaly is detected or um, a product is messed up on the product line. It helps ensure that so the anomaly detection is used to identify defects in the product and it ensures that all the qualities of the product are the same. But if, say, it's a teddy bear and one of the eyes is missing, that would be flagged as an anomaly and a measured because it has that characteristic of missing an eye. But if I have a teddy bear that has both eyes, both all arms, all legs, then that would then pass through because it meets all the characteristics. But since the teddy bear beforehand didn't have an eye, it was missing a characteristic, so it would be flagged as an anomaly because it's pulled apart from the norms. And then lastly, we have predictive ma- predictive maintenance and industrial equipment. This anomaly is employed to monitor the performance of machinery and equipment. It when the equipment deviates from normal operating conditions, then the anomaly is flagged and it indicates potential issues, allowing for the users of the machinery to maintain maintenance on it or to just prevent from it breaking down in general. Using this anomaly detection can actually lengthen the a lifetime of the equipment. And that's the end of the video, guys. Thanks for listening to me talk about anomaly detection. Have a great day.